Loops such as while and for are something we take for granted in many programming languages we use. Just for fun, I looked at the codebase of the application that my company develops. We use the for loop quite a lot, over 200 times, but I found only a single occurrence of the while loop. And when I took a look at that code, I realized it could be improved by replacing that while loop with something else. So I started wondering, is the while loop disappearing? Should we still use the while loop at all? The answer is complicated as always, but in essence, no, you shouldn't use the while loop anymore, except for a few particular cases. If you're new here, I'm Arjan, I'm a computer scientist and software developer. And on this channel, I talk about programming and software design. If you're not new here, I redecorated. I hope you like the new design. Anyway, let's dive straight in with an example. Let's start with the textbook example of using a while loop, user input. I should learn how to type. There. So we're reading an input from user from the keyboard, and then of course we expect the user to write either yes or no. So if the user doesn't do that, we need to repeat asking for a value until that happens, which is where the while loop comes in. And this is what happens when I run this program. Unless you're building command line tools, using these kinds of input mechanisms is probably not very common for you. What you will use loops for a lot is traversing data, like going through lists and doing things with items in a list. Let's look at another example. So here we have a simple list of strings, and I'm going to use a while loop to print out all the elements in the list. This means we're going to need a variable to keep track of where we are in the list. So let's create that variable. And while that variable is less than the length of the list, we're going to print out the item. And after that, we increment the variable. So if I run this, we get this. Let's make it a bit more interesting and let's do something with the elements of the list, like converting them to uppercase. And then this is what we get. Now obviously in Python there are much shorter ways to do this. Actually, printing a list you can also just do like this, but that's going to look a little bit different. Let's look at a few other options for printing out the elements in the list. One is using the for loop. And what you can do is to kind of mimic the behavior of this while loop is actually have a range that goes from 0 until the length of the list. And then this is what we get. An even shorter way of doing this is using iterators. Lists in Python support iterators natively, and that means that with the for in you can just go through the items in a list in a very natural, short way. And then this is what it looks like. Let's rename this to item. And then again, I get exactly the same result. So that's with for loops. Another thing you can do is use something called list comprehension. And that's kind of a combination of such a for loop and creating a new list with changed data. So for example, if I want to have a new list, a copy of this list, but with uppercase letters, I can use list comprehension for that. And this is what it looks like. So I'm creating a new list, but each element in the list is the uppercase version of items in the original list. And let's print out this list just for good measure. Then you see we have an uppercase version of the list. List comprehension is therefore a syntax extension that allows you to combine creating lists with the for loop in this way. So for each item in the original list, I want the uppercase version, and then I'm creating a list of that using the list comprehension mechanism. Yet another thing you can do is use something like the map function. The map function takes as an input an array or a list and a function, and applies that function onto each element of the list, and then returns a new list with the updated elements. And you can use that to do something very similar to what you see here with the list comprehension. I could, for example, use the map function to print all the elements in the list. So the first parameter of my map function call is the print method, because that's the method I'm going to call on the item in the list, and the second one is the list. And in order for this to work, because map normally returns an iterator and we need to turn it into a new list in order for it to actually run the commands, so we need to do it like this. And then you see here it also prints out the elements in the list. As a variety, let's translate this example that we had before of the list comprehension into using a map instead. So I'm creating a new list, and that's also a combination of list and map, and the map is going to turn each item in the list into an uppercase version of that item. And for that I'm going to use something called lambda functions. A lambda function is basically an anonymous function, so it's a function without a name, but it's just used as a placeholder for the map function to call. And what it does in this case is it takes the item I and then it turns it into an uppercase item. And this is what you get when you print out the result. A lambda function therefore is nothing more than a function that takes some arguments, that returns a result, but that doesn't have a name. It's simply there for the map function to use to change the elements that are in the original list. So as you can see, there are lots of varieties of traversing a list and doing something with the elements in a list. Whether you're using a standard for loop with an iterator, whether you're using the map function, whether you're using list comprehension, there are lots of options, and all of these have been added to the Python language over the last years and last decades. And often these type of functions or syntax structures are easier to use than the traditional while loop. Yes, so you see here the traditional while loop is actually pretty verbose in that you have to create an extra variable and make sure that you're also incrementing it all the time. The syntax extensions like for in and the map are there to make your job as a developer easier. Because one of the main problems with the while loop is that there are no guardrails. It's very easy to create an infinite loop. In this example where you're traversing the list, if you forget incrementing the I variable, then you have just created an infinite loop. It's very easy to do. In this example, if you replace the and by an or, well actually just for fun let's do that, then you also create an infinite loop. Because it doesn't matter what character you type, it's never going to adhere to this condition. It's not possible. And I've been here a lot of times when these logical constructs become a bit more complicated. Should you use and, should you use or, and then if there is a not involved it can become pretty complicated, and it's really easy to make a mistake and introduce an infinite loop. In this case it's not so bad because there's still user input reading in between, so it's not like your computer just goes into a frenzy. But in the second example, where if you're traversing a list and you're forgetting to increment this I variable, then it's just going to continue on forever. So the while loop has no safety net. Whereas with the other mechanisms, such as the for in loop or the map, it's much harder to accidentally create an infinite loop. Overall, if you're still using while loop for traversing a list, an array, or work with any kind of structured finite data, don't. There are much better options available for that, such as the for loop, list comprehensions, or if you're a functional programming enthusiast, map and filter. So when is the while loop still useful? Well, in a few cases. First, if you're working with data or data structures that are in theory infinite. Think of linked lists, binary trees, those kind of things. Or if you're reading data from a file stream or a network and you don't know when the last bit is coming in. Also, if you're writing specific algorithms where the stop condition directly depends on the result of what happens in the body of the loop, is a case where you'd use the while loop. For example, in the user input example showed in the beginning of this video. Or if you write an iterative algorithm that continues until the result is below a certain error threshold. Specifically, algorithms like gradient descent come to mind here, and this probably holds for most other algorithms used in machine learning as well. And finally, there are some system architectures that depend on having an infinite loop. Think of physical simulations or games and graphics engines that have an ongoing render loop. The cases I just mentioned are all pretty low level though. Most developers are not going to write those algorithms or systems themselves, but they will rely on a platform or a library of some sort. Which means there's probably no reason for them to use a while loop. The second thing to note is that in those cases you might not even use the condition of the while loop, and you just write while true to have an infinite loop, and then you break out of the while loop under particular conditions that you check in the body. Some languages actually cater explicitly to this use of the loop. For example, Rust has a beautiful explicit unconditional loop. And this looks a lot better to me than while true, which kind of feels like a hack. So we have all these different options for looping and iteration in Python. But what if I take away your candy? No loops for you! Can you still write programs with repeating parts, even if you don't have while or for loops? Fortunately, we can always rely on our good old friend, recursion. This is the general structure of the while loop. There's a condition and there's a body. And while the condition evaluates the true, we run the code that's written in the body. If you want to translate this into a version that uses recursion instead of the while loop, this is the equivalent version that you should build. There's a function, in this case I'll just call it loop. In the beginning of the loop we check the condition. If so, we do the same thing that we were doing here in the body of the while, and then we recursively call the loop function again. So let's translate this into a recursive version that doesn't use the while loop. And we can use this structure to achieve that. So I'm just going to comment this out, and we start also here with a variable I that equals 0. So this is what it looks like. There's one caveat here. Normally you don't have access to variables that are declared outside of the function unless you explicitly tell the function that these are global variables that you're using. Otherwise Python will just redeclare them for you inside the function. So we need to add here one line saying I is a global variable that we're using, and this is not a variable local to the function. So let's run this example, and then this is what we get. Again, exactly the same thing. Now this is an interesting, funny exercise, but it's obviously not something you're going to use in real life. Here it's still pretty okay-ish to do it like this, but as soon as you start introducing nested loops and things like that, this is going to get complicated really quickly. So here's another example which has a nested for loop that actually for each element in the list prints out that element with spaces between each of the characters. I followed that same procedure here but for a nested version. So you have a loop function that has these global indices I and j, and then there is an inner loop function that's also recursively called here again, and then this is what it looks like. I mean, it works, but I mean, this is obviously not really nice code, and you definitely don't want to write this stuff in production code. But you know, let's run this just for fun, and then this is basically what you get. So this is the first call, so this is the nested for loop, and here we have the recursion version that does exactly the same, but it's just written in a very crappy, non-intuitive way. So that's one practical reason why relying on recursion for loop-like structures is generally a bad idea, because it just complicates your code, and it's better to have code that's more simple so everybody understands it. Another problem with recursion is that the performance is really bad if you compare it with regular loops such as while and for. And I made an example to show you what I mean. So obviously we can't have a discussion about recursion without using a Fibonacci example. Fibonacci is a sequence where each number is the sum of the previous two numbers in the list. So that lends itself very well to recursion solution. And it's basically the textbook example that everybody uses to explain recursion. Even though I think the times that you would actually use Fibonacci sequences in production code is like never. I mean, when would you actually use that? This function is a for loop version of the Fibonacci sequence. It starts with numbers 1 and 1, and then just uses a for loop to go through the range and times to compute the new number. The version that uses recursion is a bit different. If it's 1 or 2, then both of these numbers are going to be 1 because they're the first two numbers in the sequence. Otherwise, it's the recursive call of Fibonacci recursion of n-1 and n-2. It's pretty standard implementation. And what I did here is I store the time before I call the Fibonacci function, then I compute a Fibonacci number, and then I print out the time. So for the for loop version, if I compute the 40th Fibonacci number, this is what we get. It's a pretty small number. But if I change this to the recursion version, it's a cool band name. And now look what happens when I run this code. I'm gonna get a coffee. Much better. So this is absolutely ridiculous. It took almost 27 seconds to compute the 40th Fibonacci number using recursion. I mean, this is an old computer. It's an iMac from 2016. But still, 27 seconds, that's ridiculous, really. This just shows that if you use a recursive solution, there's a significant performance cost. The reason why recursion is so slow is because whenever you call recursive function, it pushes another frame onto the stack, which is one of the two memory models that we use in programs. There is a stack and a heap. And for this particular recursive function, we're actually doing that 2 times for n-1 and for n-2. So that just adds a lot of frames onto the stack. And that makes your program really slow. And if you do this too much, it may actually lead to other problems, such as the well-known stack overflow. There is a way to solve this that's called the trampoline trick. And then you have to convert your recursive function into a tail recursive function, which means that the last statement in the function is the recursive call. And then the extra wrapper function, which is called a trampoline, is then responsible for calling your recursive function and pushing it onto the stack and popping it again from the stack. Basically behaving like a trampoline. Now, I don't want to bore you with the implementation details of the trampoline trick, but there's a link to an article in the description below if you're interested in that. Clearly, we're not going to replace all loops and iterations in Python with recursive function calls. But the idea is not that far-fetched. Functional programming languages like Haskell actually don't have loops, so the go-to solution is recursion. But in these languages, it's generally not a problem, because the syntax and the way that the programs are compiled are optimized for that. For example, this is how you write the list traversal program in Haskell. Look ma, no loops! So let's loop back to my question in the beginning. Is the while loop dead? Probably not. But there are better options that you should consider first before using a while loop. And for those cases where we still need a while loop, perhaps it's time to add an explicit unconditional loop to Python like the one in Rust. Let me know what you think in the comments below. Don't forget to subscribe, hit the notification bell if you don't want to miss out on any of my content. Thanks for watching, take care, and see you soon.